Welcome back.
Yeah,
Hello, we are back with another amazing workshop. So I'm Anarita Marrano from UMass Boston.
I'm Claire Gahagan. I'm from Agriculture Canada.
And I'm David
And
LeBauer from the University of Arizona.
yeah, so as usual, we will start with a short introduction about PhenomeForce and about this workshop, and then we will go on about introducing the speaker of today. So as you know, we are PhenomeForce. We founded this platform about 1 year. Oh well, 1 year ago, and so with the main aim of bringing together all the stakeholders that works in plant phenomics. So we wanted to build a network of beginners and experts so that they can share knowledge and build collaboration. So the first objective then is to connect people, but also we want to empower early career researchers and to create a library of open source resources that everybody can access and use it. And so with this in mind, we decided to start organizing free online workshop. And here we are at the third season already. And today there is not Felipe Matias, but he's among the co-founders of these platforms, and you will see him again in the screen next week. No, in 2 weeks. So for this season, we have a collaboration, and so Dave, do you want to talk more about Drone to Phenom?
Yeah, so I'm working with a group including Felipe Matias, Max Feldman, Jennifer Lakowitz, Adrian Silva, and myself. And our goal is to do a survey of the community to find out what the barriers are to making use of UAVs in phenomics, in field phenomics, and also to develop baseline pipelines and protocols to support standardization of UAV data collection, sharing, and analysis. And so we've teamed up with PhenomeForce in order to bring this series of talks, which are really focused on protocols and best practices for making use of drone data. So.
And for today's speaker, we have 3 speakers actually, and it's going to be a bit of a shift from our previous drone workshops where we were talking about the data itself to looking at more of how to share your data using different public clouds. So we have 3 speakers today. We have Jinha Jung, Brian Barker, and Jose Landivar. So we're going to have Jinha's going to tell us a little bit about the breakdown of their talk today. And then us PhenomeForce people will be here, but we're going to fade to the background and let the stars of the show take over.
Yeah, welcome guys, and enjoy the workshop. And of course, I forget, but if you guys have any question from the other speakers, you can write them on the chat. We will stop them and ask them to answer. So feel free to ask any question or any doubt that you have. And so have a nice workshop.
Thank you, Claire, Anarita, and David for the great introduction. My name is Jinha Jung, and here I'm sharing my screen to show the schedule of today's workshop. So I'm gonna kick off by starting talking about what this workshop is about. Plan to spend about 20 minutes for this one. And to that one, Brian from Oracle is going to come in to talk about what is Oracle Cloud Infrastructure, and he's going to go through the process how you can actually create an account with $1,000 credits so that you can test these things out. And Jose Landivar from Texas A&M Agri Live will come next to talk about how to create a new instance with a specific operating system. In this case, we're going to use an Ubuntu. Then I will just take it over from there and show you how to configure web servers within the instance, and how to share REST data as an example the today's workshop as in a time map service, so that you can share that link to the others, so that others can see those REST data set to the web as in a web service. And at the end, we're gonna have Q&A section, reserved for 10 minutes. But that doesn't mean that you cannot ask a question in the middle. Feel free to ask a question. We are more than happy to answer those questions. So to get started, I'm gonna talk about. I prepared in a very brief presentation for I'm gonna say about 10-15 minutes, and I want to talk about 10 the greatest invention that we had over the last 1,000 years. And this is not something that I compiled. I just I got this from the link that you can see at the bottom over here. And I'm just going to go over those 10 the great invention that we have over the last 1,000 years. Number 10 is anesthesia, and I think that without this, there's gonna so many people is gonna die. So there's no doubt about it. Why this is a great invention, invented in 1844. Number 9, this is in a gas powered tractor, and this is PhenomeForce related to the agriculture related in a workshop, and you all agree that without this the gas powered tractor, probably in old days we were relying on animals and human powers to do a lot of field work, and this revolutionized how the wheat productivity in the field. So there's no doubt about it. Invented in 1892. Number 9 is airplane. These days, all the travel, especially here in the United States, we do by airplane. So, we cannot imagine the life without this airplane. How we're going to actually travel to. For example, I traveled to ASA meeting last week in Utah, and I'm in Indiana. Traveling by car is going to take a lot of time, but by plane, I can just go there, relatively quickly. So this is the great invention that is indispensable from our regular daily lives. Computers, I think you all agree with that, because without this computer, probably this kind of workshop is not even possible, because everybody should be in the same place to meet. But nowadays, we have computers plus the network, internet, and we can have this kind of meetings at the large scale, very, very easily. Plus, a lot of the calculation that we used to do manually can be automated, and all those the invention of those more advanced AIs and machine learning. Without this computer, it's not going to be impossible. And this was invented in 1939, not long time ago, surprisingly. And number 6 is vaccination. I think with this COVID pandemic, everybody realized that how important it is to have vaccination available. So I don't think I need to highlight that. Number 5, radio and television. 1895 and 1926, and probably this radio and television is replaced by other medias these days, like YouTube, like you're just watching this workshop do right now. Radio might be replaced by podcast, because I don't think I'm listening to radio anymore. Whenever I like to listen to something, I'm going to rely on a podcast. But it used to be one of the very important the invention or things that we need to have in our daily lives, for sure. Number 4, telephone. I think that this is also integrated into our smartphone. Smartphone become the boundary between the phone and computer becomes less obvious and integrated into. But it is no doubt that this telephone is one of the great inventions, because with this cell phone we have means to communicate with a person that is far away. Number 3, automobile. We use it every day. Without this, definitely, that is going to be very hard life that we need to do. And number 2 is electric light. That is that makes our life we can live, we can do things even after sunset. So with this, we can actually work on a longer period of time. I'm not sure if that is necessarily a good thing or not, but this is one of the great invention for sure. And probably I can just do some kind of drum roll over here. Probably I can just play some music. I don't know what kind of music that I'm going to play, but this is the music. I'm not sure if you can hear. Probably not. I don't know. But anyway, the number 1 is printing press, invented in 1450. This is the invention that was invented the longest ago. But if you think about why this is the most important invention so far in past 1,000 years, and the way that I think why this is important is because before this printing press, information was mainly controlled by people with power or rich people. For example, if somebody wanna read a book, probably in old days the people with enough money can hire somebody to write a book for them, and that is going to be only way you can share information with the people, and reproducing those kind of information requires a lot of money and human resources to do that. But with this printing press invention, the printing a book becomes so easy, and now all the people with who is not as rich now can have an access to those kind of books, and now that means they have an access to all those kind of information. And there's a reason why people believe this printing press is revolutionized how people access to the information. And looking at right now, I think the same kind of thing is happening right now. If you look at the mass media, let's make an example of the video production or live streaming production. In old days, in order for you to develop this news, for example, you look at here, there's a professional anchor sitting here, professional cameraman, there's going to people who is controlling the light, there's going to people who is looking at listening to the audios. This is one side of the story. There is another side of the story where there is going to bunch of people sitting in the control room. They're going to be switching their videos, make sure that the other side is ready. So producing this kind of video content requires a lot of people and resources to make this happen. But nowadays, like you're just looking at this YouTube live stream, we are not a big company. And just for example, give you an example, this is how it looks like from my you're looking at this the screen, this camera right now, but the view from my side is something look like this. I have a two lights so that I have a good lighting condition. I have a the monitor that shows me my current the view that is going out. I have a dual monitor setup over here. I have a the camera that is feeding my video feed to the system. I have a stream deck so that whenever I need to complicate a macro, I can assign to a single key so that I can assign to different screen. For example, I can switch to, for example, this another Chromecast view over here. I can overlay myself on top. Probably if you see my screen over there, or I can just turn it up, come back. I as a one man, I have way to control everything over there. And you see that this is an audio interface with the microphone connected. I can press this button to play different musics, and this is a video switcher so that I can switch back to different video sources and etc. So all this kind of stuff that requires a lot of people to produce this kind of video material. Now I can just do it by myself, and to me it looks almost like an invention of printing press. In the old days, in order to produce a book, it requires a lot of human resources and money to make that happen. But nowadays, producing this kind of video material becomes easier and easier. And looking at this geospatial data in a science, a similar pattern is happening. In old days, in order for you to collect the remote sensing data set, it requires huge investment, initial investment to make that happen. And that is, you need to have a platform to collect this remote sensing data set, sometimes be in helicopters, airplane, and probably this kind of airborne data collection might happen at the the company level with the pretty good sized company. But if you go to spaceborne the category, this been mainly dominated by at the national scale. For example, here in the United States, we have a NASA, and the European, the European Union has ESA, over there, and every country has their own spatial agencies that to collect this kind of data collection to happen. So platform itself is cost a lot of money to to do that. But another thing that you need to also to pay attention is that the actual sensor itself. And this is one example of airborne metric camera system that you see. I believe this is from Leica, and this costs you a couple of $1 million. The sensor itself, And of course, this will give you, very, very high quality images, being collected and coming out of it. They have, survey, GPS, and IMU, and all those, bells and whistles, are there. But looking at, this kind of, traditional motion sensing data set, collection platform requires a lot of money and resources to, make this happen. But nowadays, we have a UAVs, and this is example of UAV platform my research group is operating right now. This is DJI Matrix 300 with L1, which is a LiDAR payload. And for this kind of platform, you can purchase somewhere around $20,000. Of course, $20,000 is not cheap, but if you go to low end DJI PhenomeForce series, you can invest a little bit more than $1,000, and you can generate very, very good high resolution the survey grade geospatial data set coming out of it. So, the people all talk about these days, fourth industrial revolution. And the key of those, fourth industrial revolution that I believe, this is also a quote from the former, CEO of, Intel. Data is your new oil, because, with this data, like, oil, make those second industrial revolution happen. Data is going to be the main resources to trigger this fourth industrial revolution. And I want to add one more keyword here, which is geospatial data. And that the slide that I'm showing over here is data is newer, because nowadays every device is generating the data. Now we have UAVs to generate a lot of different data sets. So I believe this geospatial data is going to be another key aspect in this fourth industrial revolution as well. And a lot of times people think about how to extract the data. This if I make analogy to these UAVs, how we collect the data is very important. But the extracting the oil is not all that you need to do. You need to refine it to make the usable data product out of it. So going back to here, next slide here, if I make analogy of oil industry, you have oil field where you're going to extract all the oils from the ground. That is going to be the compared to the UAV data collection. But as a final end users, probably they don't care where those oil is coming from. What they're interested is all those data product that is being refined from this oil that is extracted in the field. So this is the most important part, or final end user. These are the things that they we use in our daily lives. So, the going from this oil extraction to actual data product, these are all the previous PhenomeForce workshop that we've been talking about. Once you collect the data, how we're going to process this into specific format so that we can extract information coming out of it. Then we're going to use this for other the research. But I believe there is one very important aspect that has not been looked after so far, which is establishing all this in a pipeline. Not only we extract the oil and also in the developed data product, but how you can actually distribute all this developed data product to the final users. And this is the main focus of this workshop today. Collecting data is great, developing data products is also great, but how you can actually deliver this final data product to the final end users is going to be something that is very, very important to make this UAV based and how to phenotyping system to be useful. And my research group, we call the Geospatial Data Science Lab at Purdue University. We have four main pillars in our research group. First one is big geospatial data, which is the UAV, airborne and spaceborne. My research group is involved in all different scale geospatial data collection and analysis as well. And another aspect is in high performance computing, because as we have more and more the data is being collected from different motion sensing data collection platform, the complexity of processing this kind of data set becomes more and more. So how we can utilize this high performance computing, the high performance computing infrastructure to make this happen is another area that my research group is focusing on. Third one is data driven AI. And these days, all this deep learning is based on data driven. So how can actually use this big data set to develop machine learning or artificial intelligence model for different applications. And of course, we are also working in the agriculture discipline as well. First one is in a FAIR principle. I think if you are involved in this open data science initiative, probably you heard about this term a lot. FAIR stands for the findable, I believe. A is accessible, I is for interoperable, and R for reusable. So data need to be fair, which means you should be able to find it, and you should have access it. You should work with other data set, and we should have to use it again for other purposes as well. And at the center of this, we believe that we're gonna need to have some kind of infrastructure to make this happen, and we call this Geospatial Data Hub. And we've been working on this area for quite a years, and we're trying to develop a online platform where all those geospatial data set can be centralized, and also final end users is going to have easy access to those kind of resources. And this is example of UAS hub that is developed when I was in Texas A&M system, where we collect the UAV data set, goes into this in a pipeline. This is going to be a all refining process. Then those the intermediate data or final data product is going to the database and the file storage, and we develop custom server side the algorithms, and provide web services to all different layers. So the end users can have access to raw data set, or for example, intermediate data product like a level 1, level 2. They can even do the on the fly data analysis if they want, all those kind of stuff. And we started with start to work with Oracle, because initially it started as a Texas A&M project, but there are more and more the institute and the entities are getting interested, and how we can transfer this kind of infrastructure to other the entities. Because it gets complicated, because we are implementing this as on-prem resources within Texas A&M, but replicating this into another agencies is going to be quite complicated problem. So we start with work with an Oracle to implement this UAS hub design in Oracle Cloud infrastructure. And we ended up implementing different hubs. UAS hub, this is the one that we that we've been using in Texas A&M system. We developed in West Texas Cotton Hub. Wheat Hub is another recent USDA funded project that we are getting involved. And we are also developing LiDAR hub as well, that is specialized in LiDAR. And I wish I have time to show all those hub in a live demo, but with the time limit, probably that's not a good idea, because I'm going to be talking about demonstrate this for probably a whole hour. So I'm going to stop here, and Claire or if there is no question, next speaker up is going to be Brian from Oracle.
Perfect, thank you. I'll add Brian in and switch to Brian's screen. Whoop.
Can everyone see my screen okay?
Yes.
Okay, so I'm just showing the Oracle for Research website now for just to kind of know our affiliation. Everything look okay?
Sorry, I think Claire, you're still sharing my screen, I believe.
Let's see. Mine is showing the Oracle for Research homepage to get some nice branding here.
That should be the right one, right, Jinha?
Yes.
Perfect. Okay. Sorry about that, Brian.
No problem at all. No problem at all. So yeah, thanks for inviting me to speak today. We've had the pleasure to work with Jinha and his team for about a little over a year now on the UAS hub, and I'm really thankful to be here to be able to talk about Oracle Cloud infrastructure at a high level, the Oracle for Research program, so how we're supporting research on our cloud, and also provide some information on how you can get going on Oracle for Research today, if you'd like. So a lot of times when I talk with researchers in my role, the main question or response I get is, I didn't know Oracle was in the research space. I thought you're just a database company. And I'm here to talk a little bit today about how our cloud, our Gen 2 cloud, is a lot more than that. So for background, I'm what's called a research advocate on the Oracle for Research team. What I do is I try to find researchers in the North and South America territories, speak to them about our program, and really try to be their main point of contact. Once they're in our program, and we work with them over typically over a year period. I have a background in research myself, so I try to help gear our program towards pain points or specific needs that researchers are going to have. I'm going to try to leverage my experience to do that. So let's touch back again on what I said. I usually will talk to researchers and they'll say, I didn't know Oracle was in research. I didn't know they had all of these offerings that they have. I just thought they were a database company. So yeah, with the launch of our Gen 2 cloud, we offer a variety of services just beyond the traditional database. We offer things like compute, specifically HPC, bare metal compute. We have plenty of options for storage. We have blockchain services, things that try to enable easier analytics and AI. But what I want to focus on in the talk is some of our offerings that may be more prevalent to researchers. I think that's why we're here. How can we do better research on Oracle Cloud? Some of the offerings that we have through OCI that I just want to talk about at a high level quickly. I have a few. The main is on-demand computing. So we work with a lot of researchers who do on-prem computing. You submit jobs to your on-prem cluster. Maybe they'll run that day, maybe they'll run in 2 weeks, maybe they'll crash. So one of the big benefits that researchers see through using Oracle Cloud is this on-demand access to a variety of compute shapes, which include HPC shapes, GPUs, and we really have a variety of different hardwares that researchers can choose from, which we've seen has been a big benefit. One thing too that researchers enjoy is that you have that root access or the admin privileges. So this is really your sandbox that you get to work in. You get to control the environment. If there's software that you need, you can install that directly onto your tenancy. So you have a lot of freedom in what you can do on Oracle Cloud, which is also a big benefit. This really is your environment, and you can do with it as you like. We have a very open cloud, so as long as that software tools, etc., you're using is either open source or you have a license for it, you can kind of lift and shift that over to our cloud, which is a big perk. Obviously, one of the big things we're talking about today is data sharing. And I think I saw in the comment someone mentioned, how do we set up an environment, or how do we come up with a workflow to allow for multi-institutional data sharing? And that's actually another big positive that we hear back from researchers, is that this is a virtual platform where researchers can come together from different institutes, different departments, even really different countries, and share data, contribute data, and work on that data all in one consolidated environment. We actually just had a project that involved 30 research groups from around the world working together on a single data set or multiple data sets in one environment. So that collaborative aspect that we can provide, and the ability to share and manipulate data in one spot, is a big perk of Oracle Cloud. So I don't want to spend too much time kind of running through the OCI offerings in a lot of detail. Feel free to reach out to Jinha or I if you have any additional questions or want more specifics. What I'm kind of leading into with those specific offerings that I mentioned, though, is Oracle has an arm that is trying to extend into research and try to support research around the world, and that's the organization or the arm that I belong to. So as I mentioned, I'm what's called a research advocate on the Oracle for Research program. What we are is we are an arm of Oracle that aims to support research being done in academia, nonprofits, or government institutes, by giving researchers a couple things. So in the United States, we tend to work primarily with academic researchers. So I guess we had this great collaboration with Jinha and his team. And what we do through these collaborations is we typically partner with researchers on a one-year project in their lab. So what we do is a couple things. So we provide free access to Oracle Cloud. That's one of the big benefits of the program. So a researcher can get access to Oracle Cloud, set up an environment, run their workloads, and we help support that. We also do some technical consultation. So depending on the type of award that a researcher gets, we can work with them closely to make sure that they get up and running on Oracle Cloud, and then we make sure that their project is successful along the way. We do some, PR marketing. So, if you get a great paper or you get a grant that you're really excited about, or you develop a new tool or software, that's something that we can help share and really spread the word about. The great thing about our program is I get the fun job of just going to researchers and saying, how can we support your work? So I go out and just but we're not tied to sales in any way. So this is a program where, like I said, I get to go and say, how can we support your research? At the end of the year, it's up to you. You can go back to your on-prem. You can stay with us if you'd like, but really that flexibility is there. We just try to support research. We don't take your intellectual property or data. We value the security and privacy of your work, and I understand from my background in research how important that is. So that's a very quick overview of the program, very high level overview of OCI. I know Jose is going to get into more of the specifics, so I don't want to steal his thunder. But the other thing I wanted to touch on is, you heard about the program, you heard about some of our OCI offerings. So how can you sign up? How can you get going? How can you use this platform for your research? And there's currently 2 ways to do this. So we're happy to announce actually this week 2 new awards through our program. So you can see our newly renovated website that was also launched this week. It was a good big week for us in terms of new features, product launch, things like that. So I'm showing you our current website, and if you go to our website, oracle.com/research, and you scroll down, you can start to see the tiers of awards that we have. There's 2 options for you. I think the first one that I would recommend here is what's called our Oracle for Research Cloud Starter Awards. What this award is it will give you $1,000 to get onto Oracle Cloud and just start trying the platform. You can put data on there. You can start trying to do some processing. It's a really easy, fast way to get onto Oracle Cloud quickly and try out the environment and just see how it may benefit your research. So if you click on the sign up for $1,000 in cloud credits, it'll take you to this page, and it's pretty easy. So what you do is you come in here, you provide an institutional or business email address, and then you provide your country of origin, and you hit submit. Once you provide this information, your request will go through just a couple quick checks on our end. And if you are approved, and this approval process is, like I said, tends to be pretty quickly, you'll get instructions on how to redeem an account that'll be provisioned with you with $1,000 in cloud credits. So like I said, the cloud credits will be good for a year. You'll get a good feel for the environment. You can, move data to it. You can start doing some data analysis on this platform. It's a really, like I said, a quick, easy way to try Oracle Cloud. It goes beyond our traditional free tier. So our traditional free tier or trial period is actually only $300 in 30 days. So what we did is we wanted to develop, an enhanced version of this for researchers. So in this case, you get the $1,000 and you get the year to try this out. So like I said, it's pretty quick and easy. Email address, country, click submit, and then if you're approved, you'll get an instructional link on how to redeem this account from the email address that you put in on the screen. So that's the main way that you can get going on Oracle for Research and what I would recommend. The other thing that you can do is we have what's called a project award. So this is something where, maybe you do the starter award, you enjoy the environment, you see the benefits, and maybe you want to start building up a collaborative project with a couple institutes that you're working with. So you can do what's called this Oracle Cloud Project Award setting. So this is a longer application. So obviously there's a little bit more information that goes into it. Still pretty easy compared to your NSF grant or R01, but this is a little bit longer than the starter award tier that we have. Through this tier, so you'll fill out this information. You'll detail a single 12-month project in your lab. And based off of that information, if your project is accepted, we will cover the cloud credit requirements of this project for that year. And obviously, these tend to be larger projects that will be larger than $1,000. So, if you have HPC, GPU needs, if your project's accepted, they'll be covered. If you have 30 terabytes of data that would spend that $1,000, pretty quickly, this may be a better option for you. So yeah, if you are accepted into a project award category, you will get, if it's accepted, you'll get the a higher level cloud credit award to cover the computational needs of your project. With this tier, we do more hands-on technical consultations. So if you're accepted into this tier, we work very closely with you to get up and running on Oracle Cloud. We have regular check-ins throughout the year to make sure your project is going well and hitting agreed upon milestones. So this tends to be the larger, more hands-on approach, whereas the starter award is just a really great way to get going on Oracle Cloud and try out the environment. And obviously, there's still some support available with this tier as well if you have any questions. The last thing that I want to talk about, and I know I don't want to take up all the time and the kind of the great demos that are coming, is this new platform we launched called the Open Data Platform. This is a free service that Oracle provides where we make scientifically significant data sets open and available to the public. So if you sign up for Oracle Open Data, like I said, it's free of cost. You get free access to important data sets for your research. It's going to be an increasingly growing library, so just keep checking in. But these data sets, you can use them on Oracle Cloud, you can use them on-prem. This is really just an open way to make data more accessible to researchers, make it easier to share. And if you want to work with it on Oracle Cloud, it's just easier to manage. It's closer to your compute resources. But like I said, the cool thing about this is the data is open to the public. You can do with it as you'd like, whether that's with Oracle or not. So I'll stop there. Like I said, I don't want to keep going on and on. I think there's a lot of exciting stuff coming up. And I guess I'll turn it to our next speaker, who I believe is Jose.
All right, thank you so much, Brian. I'm just going to turn your screen off to make sure I get the right one up, and we'll add Jose in. And Jose, are you ready for me to share your screen?
Yes, I'm ready, Claire. Thank you.
Okay.
Thank you very much, everyone, for listening, and thank you for inviting me to the webinar. It's a pleasure to participate. That being said, I'm going to go to the Oracle Cloud, and I'm going to show you guys how to create an instance. An instance is basically a computer, and this computer we're going to use to host our website. Basically, here I'm going to have my username and password. I'm going to sign in. After that, of the top of the screen, I'm going to pick the menu. I'm going to go to compute instances, and I'm going to create a new instance. I'm going to specify a name for this instance. Let's say webinar, for example. And I'm going to pick a compartment. Basically, a compartment is a collection of related resources such as cloud network, computed instances, or the block volumes. We're gonna let the default availability domain to be selected, and this domain helps to determine which shapes are available. I'm going to click on change image. Basically, this image allows us to select which operating system we're going to use on the computer we're about to create. I'm going to pick Ubuntu in this case, and I'm going to click on select image. After that, I'm going to scroll down a little bit, and I'm going to change the shape. Basically, a shape is the template that determines the number of CPUs, and the amount of memory of the computer that we are going to use. I'm going to pick Intel, and I'm going to pick Virtual Machine 2.4. As you can see, this computer has 60 gigs of memory and and it's got 4 CPUs. I'm going to leave the default networking configuration, and I'm going to continue to scroll down the page. Now we need to generate an SSH key. This key is going to allow us to connect to the computer that we are about to create. Therefore, we need to save the key. I'm going to have it on my desktop. Okay. After that, we let this as default, and we click to create the instance. This instance is now being created, and it's going to provide us with an IP address that we're going to use to connect later on using the SSH key, basically. As you can see here, we have been already assigned with an IP address. And here on the left side, it's going to show once the instance is ready to be used. So after this instance is ready, and now it shows that it's ready and we can connect to it. So in order to connect to it, I'm going to open the terminal window. So right now I'm going to show you how to connect to the computer if you're using a Mac computer. And later on, I'm going to show you how to connect if you're using a Windows computer. We need to go to the location where we have the SSH key. In my case, I have it in the desktop, as I mentioned before. And we need to change the permission of the key so that the main admin of your computer has only access to write and read to the key file. In order to do so, we're gonna type this command and then the name of the SSH key. We hit enter, and now we enter the computer password. Now that we have changed the permission of the key, we can continue to connect to the computer. In order to connect to it, we're going to type SSH I, then the name of the SSH file. We're gonna use the default username, which is Ubuntu in this case, add, and then the IP address that we just got assigned. We hit enter, we type yes, and we hit enter once again. Now we can see that we are connected to this computer. Now for all the Windows users, I'm going to show you how to connect to a computer if you were using a Windows machine. We go to the start menu, we click here, settings, then we go to apps, and we go to manage optional features. From this list, we need to make sure that we have OpenSSH installed, these two basically, and if we don't have it, we click on add a feature. We look for them on this list, we click on them, and we install. They usually take about 10 minutes to be installed. After they have been installed, they're going to show on this list, and now we can continue to connect to the computer. In order to connect, I'm going to start the menu, and I'm going to look for PowerShell. Once it show up, I'm going to do a right click, and I'm going to open it as an admin. We click on yes. And we go to the folder where we have the SSH key file. In this case, it's also on my desktop. When you're using a Windows computer, you don't need to change the file permission in order to connect. This is because you're using Windows PowerShell. Now we can continue to use the same command that we use on the Mac terminal. So basically it is SSH I, then is the name of the key file, the default username, which is Ubuntu in this case, and then the IP address that we got assigned. We hit enter, we type yes, and enter again. And now we have successfully connected to the computer that we created on the cloud from a Windows machine. That being said, I'm going to let Dr. Jinha continue with the webinar.
Thank you, Jose. And Claire, if you can share my screen. And there's a couple of points I'd like to, clarify. Jose was assuming that you already went through that account creation process that that Brian showed you earlier. Going through that $1,000 credit. It's not going to be instant. It might take a little bit time. So probably you may not be able to follow through live what we are doing over here. But assuming that you have that account, then you're going to create your own tenancy. Then you just log in with your, the ID and password, and that this is the screen that is going to look like when you logged in for the first time. And they're going to also ask you like which region that you're going to select. I just have 2 regions over here, but you like to select the region that is closest to you. I believe in the United States they have 3 or 4 regions, but yeah, but this region might be different depending on which one you choose. But I'm just selecting this US Ashburn as my home region because I'm in Indiana, which is this is the closest region that I'm going to select to. And once you select the region, and this is how it's going to look like. And when Jose was showing the compute and instance, and he was showing this window where it shows. Give me a second. It takes some time. We have a different compartment because we are not using the same academic trial account. This is in our production account, so we have a different kind of compartment created. Probably your will look something like this. You have a root compartment without any subcompartment being created, but that's okay. You just create a new instance from this root compartment, and everything should be okay to go. And if I go to test compartment, this is the compartment that we just created, and you see that this instant webinar instance is something that the Jose just created. Quickly going through some of the stuff over here. This is in a public IP address, so this is IP address assigned to this in a specific machine, and that they give you the what is a username to Ubuntu. By the way, Jose, if you are listening to this, the webinar, can you please send me the the private key that you just download to my email so that I can log into the system that you just created as well. Anyway, so this is the Ubuntu username that is the given to default when you install this in Ubuntu operating system. There are many other details which is going to be outside of this the workshop topic. We're talking about how to set up this primary in a private network, in a public network, and etc. I'm not going to go over do this at this moment. But the process that Jose just showed you is how you can connect into this instance that you just created, using SSH. And if you're a Mac user, you can just open up the regular terminal to SSH in. Windows users, you can just use a PowerShell, like Jose showed you earlier. And another the very handy way of getting connected to this system using SSH is that there is one called the Cloud Shell. When you have an account, if you click this in the Cloud Shell, what it does essentially is they're going to be creating a virtual machine with the Linux shell, and make that shell available to you. So what I'm going to do right now is that Jose downloaded that private key. So quick very high level explanation about the private key and public key, what they are. You can think of this as almost a key to your house, and the private key is going to be the only one that you're going to have, and the server will have a public key you're going to store on the server side. So you need to have a private key to open the door to the machine. So, and these private keys you never share with anyone else. You need to have those in a private key so that you can actually log on to the other system. And Jose download this in a key to his machine, and just send me that key over to me via email. So what I'm going to do here is
sorry, Jin, I just wanted to check you got the email. Jose's just saying that he sent it to you.
Yeah. I'm not sure. I don't want to show my email.
Yeah.
But,
Okay.
I'm downloading in my local machine right now. So I just saved it over here. So I just I'm not showing my email screen to you because just for privacy. But I downloaded the key that Jose sent to me and to my local machine. Now this is another machine on OCI that you can actually log into the instance that you just created. So now I need to upload that key to this machine here. So once you open this up, actually you can do is that you can do maximize here, so that you can see bigger screen. If you click this in a 3-line menu over here, then you can actually menu to upload. So I'm gonna select this upload button over here. Then I need to either drag and drop the key file that I just created. So I have another window that I save. You're not seeing my screen, but I'm going to the directory where I download the key. So I just download this SSH key webinar that the Jose created. I'm just uploading it here. Click upload. Then they are actually uploading these to my home directory over here. It is a small file, so it shouldn't take that long, but now it says it's completed. I'm gonna hide it. So if you just do ls over here, now you see that the SSH key webinar key, this is the one that we just uploaded over here. So if you do ls-al, basically shows you that the permission of this key, and essentially this key should be private. Only you will have an access to, and by default the Linux system everyone else will have the read permission, and SSH will won't allow you to that happen. So that's the reason why you need to change mode. 600 means that as an owner you're gonna have a 6, which you're gonna read and write. Everyone else is 0, which means that don't write at all. So I need to change the permission of this key file that you just created. So now if you look at this in SHQ webinar, I'm the only one who has a read and write access, and everyone else has no the permission at all. So this is for security measure. So once you have this one, now I can do SSHI, SSH key webinar here over there. Then the ID of this system is going to be Ubuntu. And what is the IP address? Just copy the IP address here. It's going to be this one here. I'm going to paste. So if you just do this, as you've seen, seen from Jose's the demonstration here, you need to say yes. Basically, it says that this is the host that I trust. So now I'm in this system. So instance webinar they just created. Now you are into the system that you just that created over here. Okay, once you have this one up and ready. And next thing that you need to do here is this is just vanilla Ubuntu installation. They have just plain operating system installed, and they have nothing else installed over there. And first we need to install a web server. So for that one, every different Linux distribution has a different package management system, but the Ubuntu has a package management system called an APT. So we're going to use that one as a first thing that you need to do. Sudo is the command line to say that I want to run this command as a the administrator of this system. So apt update basically means that they have a central repository where you have all those the software that is being managed over there. They just basically what you're telling the the system to do is update to the latest the information about the repository. So I'm going to do that, and they're going to go to the network and get the latest package information being downloaded to local. Next, we need to install the the web server. So I'm going to do sudo apt and install. And name of the package of the web server in Ubuntu is an Apache. So if you just do that, they're gonna say that whatever required to make this happen, they're gonna just resolve those dependencies as well. And it is asking you, do you want to continue? And I'm gonna say yes. So I want to install Apache web server. So once you do this, what is going to happen is that they're going to install the Apache web server, and by default, they're going to start the web server in as well. So the way how you know that whether this is an install, go to this etc directory. They should have an Apache 2 directory over here. And if you look at this in Apache 2.com file, this should be, I believe, a configuration file. So for those of you who don't know VI editor, this is a text editor from the command line, and it's fine. I'm just showing the file how it looks like, so you don't need to know how to use it. But these are the configuration file that Apache use, and probably I'm not going to go over this configuration file, but I'm going to get one information out of this later. But I'm going to exit out. And what you can do here is sudo system control and status and Apache 2. Apache 2 basically is asking you, give me the status in Apache 2 web server. It says active and running. So by default, web server has been installed, and it's up and running. So it is, fairly easy in the process of installing a web server. We just type in 2 lines of command, then the web server is ready to go. But there is one more thing that you need to know here is that setting a web server is one thing, but because there are certain securities that OCI is taking care of, and by default, a lot of internet connection is it's denied by default. So you need to manually enable it. So SSH to this machine, the SSH SSH used port number 22. So, they opened it by default, but they only make it, you able to SSH in using that, private key and public key pair. So, which is pretty safe. So that's fine. But web service, HTTP uses port number 80, which is not open by default. So we need to actually open that port number 80 from this instance side, and also OCI has its own firewall, so we need to open up those port 80 from OCI firewall as well. So next process that we're going to do here is we are going to open up the port number 80 for web service on this instance level. So let's do that. So first we need to install firewall on this machine. So sudo apt install firewall d. So this is the name of the package. If you just do that, they're gonna just go in, so say yes, I want to install. It's gonna be fairly the straightforward in process. So they install the firewall on the local end here. Now I'm going to open up the port number 80. So sudo firewall command. I want to make it permanent. And the zone is going to be you don't need to necessarily remember this all command, but the zone is going to be public and add service is going to HTTP. Basically, it's something that the firewall make it permanent and make it public in a network, and just allow this HTTP service to be allowed. So once you do that, they said that I made a probably typo permanent. Yeah, permanent in the wrong place. So it says success. Now you need to do sudo firewall command and reload, because you need to reload this in the setup. So basically these two lines of command, what you did here is that for this instance, open up port number 80, so that every time any request coming to port number 80, this machine is going to respond. Otherwise, they're going to just block all those traffic coming to the port number 80. So we open up the port at the instance level, but we also need to open up the the firewall from the OCI level. So I'm going to minimize this. So if you go to this instance window, and there is many different the options over here, but what you need to click here is that they have a primary VNIC, which is in a virtual network card interface, whatever it is. You need to click this link over here, subnet. Whenever we just select the default option when you create the instance, they're going to create the sub network automatically. Then you just click this link to go into that virtual network. So give it a few more seconds until this loads up. Then if you go here, there is the default security list for this virtual network, which says this is in a public subnet, which means that it has the public the internet gateway attached to it. So I'm going to click this default security over here. If you look at this here, not necessarily need to understand everything, but basically it says here is that port number 22 is allowed from this is called in a CIDR notation, from everywhere. So anywhere in the globe, as long as you're connected to the internet, you're trying to access port number 22, then you should be able to log into this machine. But you don't see any port number 80. So what you need to do here is you need to add ingress, which is an incoming rule over here. I'm going to create an ingress rule over here. State list over there. Source is going to be everywhere. The CIDR rule, the notation for everywhere is going to be 0.0.0.0/0. Basically from any IP address. And IP protocol, you're going to select the TCP. And source range, port range, you're going to assign the every port, and the actual port they're trying to access is going to be port number 80, which is equivalent to the HTTP. So I'm going to just set over here. I'm going to say that the HTTP service. I'm going to just keep some the description over there, and I'm going to click add ingress rule. So once you do that, now you see this from all the the internet connection port number 80 is going to be now being allowed. Okay. You know what? Let me just show you what if we don't have this one first. I'm going to just remove it. Okay. Then I'm going to go to the compute again instance to just basically show that if you're trying to access that IP address, public IP address, it's not going to work because firewall is blocking the traffic. So let me just go here, go to the instance that we just created. Then I'm going to copy the public IP address over here. And if you open up a new tab and paste, if you just paste it here, I press enter, nothing is happening. At least they shoot some spinning wheel or something to show that it is trying. Some is my computer is very slow at this moment. You know what? Let me just close up some of the other services that I'm not using to see if that helps. Sorry about that. Nothing is happening. So basically, let me just.
It's always as soon as you're on camera that nothing works, right?
Yeah. I'm not sure whether it's just me or anyone else from the audience can give it a try. Try to log into. Oh, at least this change into X. They're doing something, but it's not loading up, right?
Right.
So I'm gonna go go to this subnet again, because what is happening here is that they're trying to access this IP address, but the Oracle firewall is blocking because port number 80 is not open. Somebody's trying to access port number 80 for that specific instance, but the firewall is blocking all those traffic times coming to that specific port number. So I'm gonna just do here and add ingress rule like we did earlier, 10 then 000 dot slash 0 TCP port number 80, and I'm gonna make it as a HTTP service and add ingress rule. Now you have port number 80 has been added, and it says the site can be reached. If I just reload it, now voila, you have now default web server that is up and running, and this is the how we install the Ubuntu, the Apache web server on this instance. So coming back here, I'm going to open up this cloud, the command line one more time. There are a couple of things that I'd like to point it out. So there is a concept called a document root for Apache web server. So let me just maximize it. So if you go here, let me just open up this configuration file one more time. If you search for document root, so you know what? This may not be the right cdconf enabled. Okay, not this one. Available. Sorry. Well, not this one. Oh, site available. I think this is the one. So okay, here you see that the default configuration file over here. And if you look at here, basically this is a configuration for the default web server, and they said that document root is set to be the vars /ww/html, and this document root is the top level directory in the document tree visible from the web, and these directives set the directory in the configuration from which web server looks for and the server web file from the requested URL. So basically what it means is that every time you type in this in an IP address, and that they're going to look for file under that document root that we just saw earlier, which is in a /var www and html. And if you see this in an index.html over here, this HTML file is going to be the one that is displayed over here. So you need to understand that Every time you just request something, if you don't specify anything over here, basically by default, they're going to open up this index.html.
Hi, Jinha. There are a couple of questions.
Sure.
I will
Go ahead.
start with the latest. They are asking if there is an equivalent written walkthrough tutorial with step we can follow. Yeah.
We don't have a written tutorial, but this record video that I'm hoping serve as a kind of almost written tutorial, because we are showing all those steps.
Okay, yeah, but if you guys have any page where you share these codes, that you guys can also share it, and then we will post it on our website or in the description of the video.
We have a steps that we develop for our own purposes, but it is not that well organized. So I'm not sure if we can share that, because they might even confuse even more, because it's not ready for public at this moment. But yeah.
Okay. So there is another question, but if you if you prefer to finish and then we take it.
I don't mind taking the question in the middle.
Okay. So they're asking is Oracle Cloud an alternative to APC?
The answer is yes or no, depending on how you use it. So Oracle has report resources to configure high performance computing cluster as well, because they do have different shapes. The one that we are looking at is the virtual machine instance, where you're gonna just have very lightweight the service being deployed and make it possible. But we tested Oracle Cloud for UAV processing, so that we can do parallel processing of UAV structure from motion to speed up. So if you want, definitely you can configure this in high performance computing cluster. Yes.
Okay, thank you.
So maybe I can move on. So that I hope that this document root is clear. Depending on how this document root is set up in that configuration file that I showed you earlier via etc apache 2 site available was the keyword, right? Available 00 default, and the default web server in document root set to be this var www.html. That's going to be the root directory where all those web services going to look for files in reference to that specific directory over there. So once we got that one, next one that we're going to do, we have Apache server up and running, and we're going to install a couple of additional packages, because we're going to give a demonstration how to share also mosaic images collected from UAVs as a web service. And in order for it to happen, we need to do time map generation. And there are a couple of ways of doing this time map generation, but we're going to rely on the open source tool called the gda2tas.py. And in order for you to install that in a package, this GDAL binary packages is by default. So if you just for sudo apt search is another keyword instead. The install is in the installing, but you can also search by keyword as well. If you do GDAL, sorry, this is not as responsive as my phone here. They do have this GDAL dash bin package available. This is but kind of outdated. So we are gonna add a new repository so that we can install the latest GDAL dash minus bin package being installed. So in Ubuntu, how to add a new repository here? Sudo add apt repository and PPA Ubuntu GIS/PPA. So basically, what you're doing here is what did I made a mistake. Typo one more time. Ubuntu GIS, right? So do you want to official stable Ubuntu GIS packages? Do you want to install and add a repository? I says click enter to add. Now they are just adding additional repository to the list. Then the next we need to do apt update to make sure that all the latest packages are being downloaded to local. Okay. Now what I'm going to do is a sudo apt install gdal -bin. So they're going to install the latest gdal bin package to local machine. So I'm going to say yes. They're going to go into the repository, install all those required the dependencies into local machine. And it may take a little bit while. And the good thing about this packaging management system is that you just specify what you want to install, and they're gonna figure out what additional packages that need to be installed automatically. Okay. Okay, now this has been installed, and now we are at the document. PWD is the command that shows you where you are at this moment. We are at this document root, var www HTML. If you just do the ls-al, this current directory belongs to root, and you don't have a write permission, so you cannot create anything because only root can do that. But what I want to do here is that I want to create a new directory called a raster example. So I'm going to just do main-k directory raster example. If you just do that, they said the permission denied because you're just trying to run this as an Ubuntu user, which is not the administrator. So what you need to do here is you need to do add sudo in front, which means tells you that I want to run this program as administrator. We just do that. You're going to see this rest example is created, but that this belongs to root and root. And as a regular user, you don't want to keep doing this sudo command. So what I'm going to do is I'm going to change the ownership of this directory to myself. So if you just do an ID, they show that this my user ID is an Ubuntu, group is an Ubuntu as well. So I'm going to do sudo ch change ownership. ch own. I'm going to change it to Ubuntu colon Ubuntu. Basically, this means that the owner to be Ubuntu in a group to be in the Ubuntu as well. And the raster example, if you just do that, just do ls minus one more time. Now you see that the owner and group is being changed to Ubuntu and Ubuntu. Now you can just do whatever you want to do inside this the directory over there. Okay, I'm gonna move into raster example. And the directory that actually downloaded, I uploaded some example orthomosaic images that I created is this one here. Let me just go over here. Type in the URL http s hub.jinha.org and outbox and ppeg underscore RGB also mosaic example .tf file. So if you just do this, they're gonna just let you download the file to your local machine. I'm not gonna do because I already downloaded on my local machine, or and I'm just assuming that you already did. Okay, and what you need to do here is you need to upload that raster file to this directory so that we can do the further processing of the time map generation. There are many ways of doing it, and one easiest way of doing it is that you already have some file that we want to download. You can just come here, and there is a command line for Linux called the wget, and provide this URL. They're going to actually download the data set in a command line automatically. So right now they're downloading from that URL that I just showed you earlier. But in most of your case, you're going to have your orthomosaics generated on your local machine, and probably you need to upload that file to this specific machine over here. So what you can do here is that since you have a way to connect to this the instance that you just created and using SSH, you should be able to log in to the SFTP protocol as well. And you need to use a FTP client that does support the SFTP. There are many the FTP client out there. The one that I recommend is FileZilla. FileZilla download. This is an open source, and please download it from the FileZilla dash project.org, because this is an official website. Just go here, and you can download from Windows. You can download for Linux and Mac. Or today down, I don't know why they let me download the Windows version over here, but you should be able to download the Mac version as well. Anyway, I have my disk in a FileZilla already installed. So if I just open up, show you how you can connect. I'm gonna just close it here, because you can only let me just go to presentation 2021 11. Let me just go here. Of course. So these are the the ortho mosaic that I downloaded into my local machine over here. Then you just click this button here, Open Site Manager. Then you need to add a new site. So I'm gonna call that PhenomeForce demo. Give a specific name. And you need to select the SFTP protocol, because that does support in a regular the plain FTP as well. But you need to select this in SFTP. Then going back to this instance, where is it? Then need to copy the public IP address. Not this one. Go to compute instance. Give me a second. Then instance webinar that we just created. And copy this public IP address. Going back to this here, this is going to be your the IP address that you're connected to, and you need to select key file, right? And user is going to be Ubuntu, and key file that you need to select. I'm going to click browse, and this SSC key in webinar. This is the one that I received from Jose earlier. Just click open. Now you just click connect. And they're gonna say that, yeah, this is host key is unknown, and do you trust this machine? That I know that this trust machine trust this machine, so I'm gonna click always trust this host and click OK. Then now you're connected to this the machine that instance that you just created. Now we need to go to var www and html. Then you're gonna see this rest underscore example. And you already uploaded this in a PPAC, RGB ortho mosaic example in a data set over there. So you can, easily, drag and drop to upload it. I'm not going to do that because I already downloaded from that link that I, showed you earlier. Okay. That is that. And to give you an idea how this data set look like, let's open up this in ortho mosaic within the QGIS. I'm opening up QGIS right now. Give me a second. You don't see nothing is happening, but I initiated the QGIS in another window. I'm gonna just bring it back here as soon as it opens up. So the QGIS 3.16, I believe 3.20, the long-term release just came out. Probably I need to update, which I haven't done it yet. Then I'm gonna open up this ortho mosaic images. As soon as it comes up, I'm going to drag and drop so that we can have a look how this ortho mosaic look like. For my laptop is doing a lot of work right now, doing a live streaming and QGIS, a bunch of the Chrome tabs, other things running. Maybe that's the reason why it is very slow. Let me see why this is still loading up. I hope my machine doesn't crash in the middle of doing something.
Hi, thanks, Gina. While we wait, I think we can take one question.
Sure.
Just
go ahead.
up. So, as a US-based researcher, I have access to publicly funded research clouds like Jetstream. Are there advantages to using Oracle Cloud instead? Yeah, so I don't know if also Brian
So
wants to come back to on the screen if he has them.
I believe probably this might be a question the Brian might be able to address this much better than I do. But it, every cloud services has the pros and cons for sure. I don't know about Jetstream, so what are the pros of Jetstreams?
Mhm.
But based on my experience with working in the Oracle, I work with AWS the Azure before. To me, most of the stuff like I like to use all those public cloud services do have a service that kind of options available. So
Mhm.
the things that you do that I'm showing at this moment right now, I'm pretty sure you should be able to do the exact same to same from other cloud services as well, like in a Jetstream. So but if you go to the specifics, probably there are other things that might stands out from specific service provider, but I don't think I have that kind of information at this moment with me.
Well, maybe I bring in Brian. Um, yeah, so I want just like, yeah, so Brian, do you have any specific thought about this question?
Yeah, I think unfortunately I'm kind of in the boat where Jinha is. I'm not too familiar with Jetstream, so I just want to be cautious of saying, what we may be able to do better or what we may not be able to do better. And maybe that's a question we can take offline and do some research on, just because I want to make sure I give an informed answer to that.
Hmm. Okay, thank you.
Okay, thank you. It was perfect timing because while we're having this conversation, this QJ is launched, and I was able to display the orthomosaic images that I'm loaded as example data set here. This is cornfield that is within the Purdue Agriculture Center, one of them, and this is the images acquired right after planting, I believe, and this is the data set acquired by DJI PhenomeForce Multispectral. It's flown at the 25 altitude. This is just an RGB orthomosaic. We haven't. I'm not sharing this multispectral data set earlier, but you can just zoom in. I think it may take time to show up, but you can see the resolution. I believe this is orthomosaic images about 1 centimeter resolution. Whether you can see the crop residue from the previous years, etc. So basically, what we like to do here is the sharing this kind of visualization as a web service. That's exactly what we are going after. Okay. So I'm gonna just not close it. But going back to this window over here and coming back here doing ls. This is exactly the file that we just downloaded. Then I'm going to check in a couple of things. So the GDAL comes with a couple of command line tools. Just maximize this window one more time. So there is a command line called the GDAL info. So GDAL info, and you just give the name of the file. And what it will do is that they will, print out all the, the metadata associated with this specific, orthomosaic images. So you can just scroll up here, name of the file, what is the size of this in a raster data set, which is in a 9200 by the 10,000 ish. And this coordinate system of this orthomosaic has a WGS84 UTM zone 16 north. And scroll down, and usually, this is represented by EPSG number. You can see that the EPSG number for UTM 16 north with the WGS84 is 326 16. So we're going to use this information later. This is origin, which is an upper left the UTM coordinate of these orthomosaic images. Sorry. And another thing here is in the pixel size. So the UTM is given in the meter. So basically, it tells you that it's going to be 0.01 meter resolution, which is in 1 centimeter resolution over here, right? And they give you the information about additional the band. It has 4 band, I believe. The RGB and alpha band as the last band over here, red, green, blue, and alpha over here. So with this in mind, that we are going to generate the time map. Probably, if you don't know what is time map, you can just think of almost same as the Google map. Every time you just open a Google map, how they're gonna just show those all those map very quickly. They just pre-generate all those in a different zoom level images and store them in as the time map, the time map format, then as you zoom in, they only show you the specific zoom level images, the area they are looking at only. Sorry about that. Since those already pre-populated the images is pretty light, you can just visualize those images very, very quickly. So there is a comment that you can generate the the tile map using GDAL tools. The command is a GDAL to tiles.py. First argument they need to provide is going to be -g. Basically, you need to specify which zoom level the unit you're going to create. And there are many the documents out there, but the one that I'm gonna just go to Google here. Town map zoom levels, for example, and many documents out there. But the one that I found the most appropriate for this kind of high resolution images is this the document from the Mapbox, because zoom level 0 means that these are the resolution per pixel, and zoom level 0, each pixel is going to be over 80 or close to 80 kilometers. Zoom level 1 is going to be 39 kilometers. As zoom level numbers goes up, basically your spatial resolution is getting better and better. So if you just scroll down, centimeter resolution is going to be somewhere over here. Zoom level 22 at the equator is going to be this much, and goes in a higher latitude, it's going to go to centimeter resolution here as well. So probably the maximum zoom level that you're going to work on is going to be about 22. If you have a sub-centimeter resolution in orthomosaic images, probably you want to generate the time map up to zoom level 23, but that's going to be very rare. So I want to generate the zoom time map up to zoom level 22, and you need to also set the what is a minimum zoom level. You can go all the way up to 0, but probably not necessary. So I'm gonna just say that let's generate the zoom level from 15 to 22. So going back to this command line here, I'm gonna set the zoom level from 15 to 22. That's the syntax that you're gonna specify. And you need to say -s. Probably you can look up the documentation of this digital to tiles. There are many other options out there, but basically -s specify what kind of the map prescription was used to generate this orthomosaic. And I know that this is an EPSG of 32616, which is WS84 UTM-16 North. And next argument they need to provide here is the input file, which is in a PPAC, orthomosaic example.tif, and you need to specify last argument is which directory you're going to store your time map to. So I'm going to say that PPAC and RGB. I'm going to just type enter. What it's going to do here right now is that they are generating time maps at the zoom level from 15 to 22 right now. So it's going to take a while, depending on how zoom what zoom level you set up. Of course, the low zoom level you set is gonna do it much quicker. Also, depending on the size of your orthomosaic, this may take hours, even some cases. And this instance we created with 4 CPU, and I believe this GDAL2 tiles has a way of the multi-threading, which I'm not using it. Probably I should have used it but I'm not using it right now. There is a way to speed up the process as well if needed. So while this is being processed, Claire or Narita, do you have any question from the audience? Any sense?
Not so far. Yeah, I think there were people asking about, I think Dave probably will want to take some of the question related with the jet stream and some other. So I probably have one question before going to that. So I don't know if also Claire wants to jump in the discussion. So thank you for the workshop. Very interesting. So I have one question related. So we mostly promote open source resources that people can use. So are there any other option that you will suggest where people can upload their data and that they are open source? And the second question that I have is related with FAIR principles. So, what are your thoughts about, so like, I think phenomics is a growing field nowadays. So I have been working with genomics for so many years, and I think it's very good now, like define some fair standards for data sharing in phenomics. So do you guys already have some idea about that? What are your thoughts about it?
So probably there might be a good item that we can have more lengthy discussion at the end. But to answer your the FAIR principle, uh, there could be many ways of addressing the issues. The one way of that I believe we can address that issue is going to be having centralized database, so that everybody can come and search from the single database to do that. Which of course will require a lot of resources to make that happen. And I believe David is part of the Cybers the NSF funded project. Pretty sure that is one of his research interest in as well. And Ag2PI, NAPPN, they are all interested in this. I think we had a another conversation. I think Dave was one part of it. How we can actually make that happen, and having everybody aware where those data sets are, so that this data set becomes more findable. So I don't think we have an answer for that question. Probably we need to talk more discuss this in the group and how we can make that happen.
Yeah.
Um,
Yeah, so actually, right now I'm the scientific coordinator of the program coordinator of AgBioData, which is a consortium of databases in agriculture, and they are working about developing standards for data sharing.
Okay.
But I think so it's a very big question, but I think open source resources are the way to go for
Sure.
making that
Yeah.
possible. But yeah,
And-
so I don't know, Dave, do you want to take some of the,
and-
like you
and-
were,
and- Narita, sorry to interrupt, but the first question I haven't answered
yes, sorry, I
about
forgot
the
about it.
open
Yeah,
source.
sorry.
Of course, OCI is not free. They give you free credit of $1,000, which is great. And also OCI has something called free tier. So as long as you're not requesting a lot of computing resources, you can still run this virtual machine with a very limited resources for free. But of course, they'll be limited in terms of how much storage space you can use within that free tier. So in that regard, we have an option which is free from you, even from OCI. But if you want talking about more scalable options, I don't think there is any options out there in terms of develop this kind of resources for free. But all the other software that I'm demonstrating right now, they are open source. GDAL, for example, is the fund OSGeo funded force project packages, open source. And my research group is using Python to do all those additional data processing pipeline development, which is in open source. Because, we are not sharing all the Python code we developed with the public at this moment. But
Yeah, but we will be happy to have you back and also showing new updated pipeline. And if you guys have any link about that you guys wants to share with the public, feel free, and we can add them at in the description of the video. Yeah. So Dave, do you want to have some words about OpenStack? And thank you.
I'd be happy to. Yeah, just so to clarify for the audience. So one of the things, most of what Jinha has presented today is something that could be done if you have an old desktop computer sitting around. You could install Ubuntu on it, install the server in GDAL, and run the exact same thing and have people download from it. I just wanted to make that point clear so that you understand what a virtual machine is. So the difference between this old desktop computer sitting in the corner and a virtual machine is it's in the cloud. And that's basically it. But by being in the cloud, you also have access to more resources. They showed how to configure it with a certain amount of memory and nodes, etc. You could take the same machine, and if you need to, just scale it up pretty quickly. So, having said that, before I get into this, to the OpenStack and Jetstream more specifically, I also wanted to point out that to answer this question from before about the difference between, I mean, I don't know much about Oracle Cloud, but between what Jinha showed and HPCs in general. So typically an HPC will not allow you to serve data, or even, launch a web server or anything like that from one of its nodes. That's not really how HPCs are designed. But now to move back to talking about OpenStack and Jetstream. So the NSF recognizing the need for computing resources, and also as part of supporting U.S. development of new high-performance computing resources, has funded a large network of HPCs. So no matter what your large-scale computing needs are, you can find something in this network, and it's all under the name of XSEDE. XSEDE is a place where U.S. researchers can get access to a lot of high-performance computing resources. And then to address the need of the type of use that Jinha is demonstrating today, basically deploying a virtual machine to provide a web service, that's where Jetstream fits in. And I haven't used Jetstream, but Jetstream uses OpenStack, which I have used a bit. And again, it's really, the interface is a little bit different, but all of the steps are pretty similar. You define the virtual machine, you set it up, now you're in your Linux box again, which would be pretty much equivalent to a desktop Linux computer, and you have all the options in the world to deploy it. And so beyond that, I would just I would say to answer some of these questions, XSEDE provides, NSF through XSEDE provides a huge amount of computing resources to U.S. researchers, and OpenStack, and Jetstream in particular is designed to allow people to use the cloud, including putting up websites and web services and etc. So yeah, those are a few of the points that I think hopefully will clarify for the audience.
Well, thank you, Dave. I think it would be nice also as PhenomeForce to have like a list, provide a list of these resources on our website so everybody can access it. That's something that maybe, Claire, we should do for the future.
Yeah, that sounds good. So I believe that's a good little foray into how we're trying to encourage open source, but we don't want to take away too much. And how are you going to show us an output from your analysis?
There's quite a lot of stuff left. So if you can bring back to where I was, I think that'd be great.
Okay, perfect.
So this time map generation finished. What is time map is nothing but hierarchy of small the PNG images. So we just created this in a PPAC underscore RGB directory. If you just move into this, you see this different the zoom levels 15, 16, 17. So for example, if I move into zoom level 19, they have a way of specifying coordinate system. They call the the TMS format. I think either they are G, X, Y, or whatever the order it is. They just store those information into this. So for example, if I just move into one of the directory here, you see those PNG files. So that's how they're going to figure out what is the zoom level, probably in X and Y coordinate. I think Y and X coordinate for the the TMS format. And there is another time map service format called the XYZ format. So if I just come right here, and I'm gonna just run this same command again, gdal2 tiles, okay? But there is one more options that you can specify, which is let me just do it here, minus XYZ, which means that you are specifying that I generate the tile map with the XYZ format. I'm going to explain why I'm generating this tile map in two different format here. I'm going to save it as an XYZ. So like I mentioned, this is going to be generating the data set, but going back to, this, window here, let me just minimize this. Now copying this in a public, IP address here. And if I just do this, they're going to give you this, the vanilla, HTML. But now we just created a directory called the raster example. And if you just, give the file name, for example, the file that we uploaded, which was in a PPAC and IGB and also mosaic underscore example TIFF. Now people can download this data set from this link, like you can show over here. So if you want, you can send that link to somebody so that they the other person actually can download this in a specific orthomosaic. This is a way of sharing the original orthomosaic data set with others, but also rest the example underscore we just sent it the PPAG and what is the PPAG IGB. And inside that, as a part of this, the Jira2000 they generate the HTML file automatics to visualize that the time map they generated, and open layers.html is going to be the one that is generated and coming out of it. As you can see over here, they just show the base map as an OpenStreetMap. As you zoom in, now you can see those, the orthomosaic that you saw from the QGIS now is visualizing within this the web browser. So you can send this link to the other the colleagues so that they can actually see this orthomosaic without for them to download, and they can just zoom in and zoom out and play with this kind of data set. Okay. So,
and is that orthomosaic you're sharing there, would you be able to share it at any sort of resolution? Like you can access the full resolution version of it that way?
Yeah. So as you zoom in, you're going to see that as you zoom in, the specific zoom level is being downloaded for the region they're looking at. That's the reason why it is going to be very quick. You don't need to download the full resolution for the whole area. You're zooming out. You're just zooming out, downloading the low resolution data set for the region that you're looking at, which is going to be usually much smaller than the full resolution data set of the whole region.
Very cool.
Yeah. So this should be in a fairly quick way of doing it. So let me go back to this the instance here one more time. Maximize to make sure that this XYZ tile is being generated as well. So I'll probably just go underscore XYZ. You're going to see the same images being shown up, but there is one advantage of this XYZ tile map, because in XY time map you can also import use this as a background layer within QGIS as well. So going back to this QGIS, I'm gonna load up a, for example, Google Map in a hybrid. And from the QGIS, you have an option here. You can add XYZ tiles. Click new connection here. I'm gonna call that the PhenomeForce Workshop XYZ tile demo. And you need to give the URL. So going back to this window here, I'm gonna copy. Oops. Probably I don't need to worry about the cut here. Need to copy here. The syntax here is in the zoom and x y.png. Now, whatever that you had that time map generated, this first folder is going to be zoom level. This next level is going to be x coordinate, and last level is going to be y coordinate.png file. So if you just specify, then you know that the minimum zoom level they created was 15 and 22, right? I think that is the one that you just selected. Click OK. Then as you just do that, I'm going to go to the PhenomeForce XYZ tile layer. I just double click. This has been added. It seems like there's nothing, but let me just zoom in to PPAC location. So here is Indiana. Give me a second. So Lafayette, this is where Purdue campus is located. PPAC is located somewhere over here. The connection is very slow. Bear with me. I'm getting there. And usually when you just do it without streaming and doing the many other stuff at the same time, it's going to be loaded much quicker. It's not going to be as slow as this. Let me make sure that I'm looking at the right 421. This is the one that is going in. The problem is that area that we're looking at is so tiny, and it is very slow. When I tested it the earlier, it shows up very quick, but right now everything is slow. So, let me see the Purdue. Oh, you see this popped up over here. So this is orthomosaic images. This is the tile map they just created actually being called from the the instance that you just created from Oracle. So you haven't downloaded any orthomosaics from anywhere, but you can still use this as a base map, and you can just do the some additional the data set being overlaid on top of this one. So I can just turn this up. So this is a Google Map background over here, and I can just check this on. Then you're gonna see this orthomosaic that is being served from this Oracle instance that we just created, and create a time map out of it. And I'm gonna just close this out. I think I demonstrated enough in terms of QGIS, and also I can reserve some of the computing resources for the later part of the demonstration. Give me a second while this is doing the work. And right now, what you're relying on is based on IP address, but a lot of times remembering those IP address is quite challenging. And you can also associate the specific domain name to specific IP address. While Jose is working on that instant creation, I had we have our own domain name called uashubs.com. And I added a new record there. It's called pf PhenomeForce.uashubs.com that is going to be pointing to the IP address that we just created over here. So we can just type in pf.uashubs.com. Then you're going to see this website. And the same example as I said before, raster example and PPAG and the RGB open layers.html. And you're going to see the tile map that you just created being showing up over here based on just domain name. This is something that you can further do it if you want as well. So I think with that, I think this is everything that I prepared for today's presentation, and be happy to answer any question that you might have from the audience.
Thank you, Jinha, for the presentation and for trying. So I don't know if Dave has a question. There are no more questions from the audience. Dave, do you have any question?
Yeah, I just had a couple questions. So I missed some of the configuration of the server, but is there a particular geo server that you installed, or is that all? This is just an Apache server.
It's just Apache, and that is a regular time map service.
Okay.
Well, with this, I think we thank you, the speakers, for being here today. Thank you so much. And of course, Jinha, if you have any other pipeline that you want to share in the future, please contact us. And
Sure.
we'd be very happy to have you.
And Before we let you go, Jinha and Jose and Brian, are you all open to being contacted if people have questions?
Sure. At least I am. I hope Brian and Jose is the same as well.
Perfect.
Absolutely.
So
Thanks.
you feel free to reach out to them if you have questions on anything they presented today. And thank you all so much for coming out and sharing your knowledge with us. We really appreciate it.
Thank
Yeah,
you.
that was really great. Thanks.
Thank
All
you.
right.
Thank you.
All right, and I guess that brings us back to what's coming up next week in the interest of not going too far over our time budget, right, Anarita?
Yes, yay, we are still on time. So as you know, we will take a break next week because it's going to be Thanksgiving holiday here in United States. So we are going to be back in December 3rd. We will have Margaret Krause from Utah State University. She will be talking about how to use hyperspectral reflectance data to predict green yield. So we will be still here at 10 a.m. on December 3rd. Here you have the registration link. If you registered for this workshop, you will not need to register again. But if you think that someone can be interested, please share it with your colleague and friends.
Yeah.
And also we go.
Sorry, just to let people know that if you do register, then you'll get the links ahead of time if there are any workshop materials that are interactive, and if you want to follow along, and we'll also send the GitHubs of speakers who share that information with us as well. So it's a good list to be on.
Yeah, and also we want to remind that we have a Slack workplace. So if you guys want to be part of this, you can just send us an email send an email to phenomeforce@gmail.com, and we will add you to the workplace. It's a good place where you can chat with people that are in your field and ask for questions. And with that, I think
Wait. If they made it this far, then they should subscribe to our YouTube channel here. Because if you're made it to the end of the video, there's a good chance you're interested, and we're going to have lots of good phenomics data coming up in the future as well.
Yes, guys, we missed Felipe. He's always the one promoting the YouTube channel. And with that, I think thanks, Dave, for being with us today. And thank you guys for being and listening to us again, watching us again. And thank Claire. Have a nice weekend. Bye-bye.
Have a good one. Bye.
Bye.